As students, now we are going to see the practical number 8, that is calibration of Ogee weir. Okay. Write on the title, calibration of the Ogee weir. Aim to determine the coefficient of discharge of Ogee weir. To determine the coefficient of discharge of Ogee weir. So in theory, we have learned this. Ogee weir is one type of the spillway. Ogee spillway is there. You might have you might remember regarding that Ogee spillway. What is Ogee? It is the shape of the weir. S shape असेल तर त्या ठिकाणी आपण त्याला म्हणतो Ogee weir. Right. Why this is preferred? Why this shape Ogee shape is preferred for the spillway? Because the lower nappe of the flowing water, okay, water ज्यावेळेस या ठिकाणी फ्लो होतं, sheet of water जे असते, that is called as the nappe. This is the upper nappe and this is the lower nappe. This lower nappe of the water or the sheet of water, it get adhere to this particular surface of the weir. हे weirच्या सरफेसला चिटकून त्या ठिकाणी फ्लो होत असते. कारण याचा शेप जो आहे, शेप देतानाच हा जसा नॅपेचा शेप असतो त्या पद्धतीने या ठिकाणी याला शेप दिलेला आहे. अँड ड्यू टू दॅट दिस nappe, lower nappe, it remains stuck to the surface of the weir, and due to that what happens, negative pressure or vacuum pressure or cavitation does not happen here. Otherwise, if the shape is not like this, and if the this particular lower nappe leaves the surface at that time, what is going to happen here? The cavities are going to form here. Okay, negative pressure will be generated, and due to the formation of the cavities, when this cavity get burst at that time, the wear and tear of the surface which is present over here, हा जो surface आहे, surface त्या ठिकाणी जीज लवकर होते, wear and tear होते. So to avoid that, this kind of shape is provided, Ogee shape. Okay, so and the spillway is called as the Ogee spillway or the Ogee weir. This is the experimental setup. Tilting flame is there. This is the Ogee weir provided here, and the flow of water will take place here. This is the measuring tank. Okay. Again, this practical is similar, quite simple, similar to the Venus practical. This is the procedure, observations and observation table that you note down. Observations first: area of the collecting tank. Capital A is equal to 0.4 by 0.4 by 1 meter is equal to 0.4 meter square. Length of Ogee spillway L is equal to 0.15 meter. Initial reading, height of the crest. So this observation is remained to take here. So when we go there to perform the practical, at that time you can note down this value, initial reading of the crest or the height of the crest. Why it is required? To find out the actual height of water above the crest. That is capital H. So observation table, serial number, point gauge readings. In that, two columns, initial reading and final readings. Next column, head of the water over the Ogee weir. Head of water over the Ogee weir. Capital H. This is nothing but final reading minus initial reading. Okay. Next, rise of water in the collecting tank, then volume of water collected and time. These are the observations for the finding Q actual. Last column Q actual, meter cube per second. Is it over? Okay. Next calculation part. Q actually is equal to A into H upon P. Q theoretical 2 by 3 L into under root of 2 CH raised to 3 by 2. Where L is equal to length of the weir. Capital H is equal to height of the water over the weir crust. QTH is equal to theoretical discharge in meter cube per second. Then coefficient of discharge CD is equal to Q actual upon Q theoretical. Last weir constant K is equal to CD into 2 by 3 into L into under root of 2. Result table. Serial number, Q actual, Q theoretical, CD, average CD. Is it over? Conclusion. The coefficient of discharge of the Ogee weir CD is equal to the weir constant of Ogee weir K is equal to. Is it over? So this was the explanation for this practical number 8. So now we'll perform this practical.